Welcome to my channel, everyone. In this series, I'm going to be teaching you about exponents and radicals, and this series will be covered over, I want to say, approximately 3 to 4 different videos, each on different sections. But in this video, we're going to be starting with the fundamentals of exponents and radicals, which are divisibility rules, prime numbers, factorization, greatest common factors, and lowest common multiples. So let's just get started. Okay, so we're going to begin by going through different divisibility rules, and if you're not too sure what it means for something to be divisible by a number, it means that basically it can be divided by the number, hence the name divisibility. So let's start with divisibility by the number 2. And this is pretty much just all even numbers. All even numbers can be divided by 2 and result in a whole number. For 2, 4, 6, 8, 10, 12, any even number is divisible by 2. By 3, however, there's actually a trick to find out if a number is divisible by 3. So obviously that's kind of easy to understand up to, let's say, the number 30 or 60. You can just do your multiplication tables and you'll figure it out. But let's say you have a big number like 12,123, For this, there's actually a trick. And that is if you add up all the individual digits in that whole number and the sum is divisible by 3, then that entire number will also be divisible by 3. So then we have 1 plus 2 plus 1 plus 2 plus 3, and that is 2, 4, that gives us 9. And obviously we know that 9 is divisible by 3 because 9 divided by 3 is 3. So because 9 is divisible by 3, 12,123 is also divisible by 3. Okay, so let's move on to divisibility by the number 4. If the last two digits of that number, let's say 12,124, if the last two digits are divisible by 4, so if 24 is divisible by 4, then this entire number will also be divisible by 4. So obviously we know 24 is divisible by 4, and it equals 6, which means 12,124 is also divisible by 4, and when divided by 4, it will give you a whole number. Now 5 is pretty simple. It's just if it ends in either 5 or 0, it's divisible by 5. That's all you need to know. If the number ends in 5 or 0, regardless of how large or how small the number is, it's divisible by 5. Now for divisibility by 6, if a number is divisible by both 2 and 3, then that number is also divisible by 6, like 12, for example, or 24, for example, There's not really a trick to know if anything is divisible by 7, because 7 is a quite unique number, and we'll go through that more later on in this video. But let's move on to divisibility by the number 8. This one is a little bit more complicated. If the last 3 digits are divisible by 8, then the entire number is divisible by 8. So if we have the number 6008, since 0, 0, and 8 are all divisible by 8, then 6008 will also be divisible by 8. And then divisibility by 9 is similar to the rule of divisibility by 3. It's just where you add up all the digits in the number and that sum is divisible by 9, then that entire number will also be divisible by 9. And divisibility by 10 is really simple. It's just if it ends in 0, it is divisible by 10. Now these are just tricks to help you learn what is divisible by each of these numbers listed. Okay, so now that you know this, we can move on to prime numbers. Okay, so what exactly is a prime number? And the answer to that is a prime number is a number that only has factors that are itself and the number 1. And factors are things that are multiplied together to come to that number. So for example, factors for the number 2 are 2 and 1 because 2 times 1 is equal to 2, and those are the only two numbers that will give you 2. Nothing else when multiplied together will give you 2. Another example of a prime number is 3, which has the only two factors that are 3 and 1, because again 3 times 1 is 3. And then some other examples that follow the same pattern are 5, 7, 11, 13, 17, so on and so on. Just a fun fact, any number that's not a prime number is a composite number, other than 1. 1 is an exception because it's not a prime number and it's also not a composite number. So that's basically what a prime number is. Now, a very important concept is prime factorization, and this is actually very simple, although it might take some time to understand. Basically, it's to help you find factors of larger numbers, so it's easy for prime numbers, 2, 3, 5, and 7. You already know that only that number and the number 1 are its factors. But if you have a larger number, like how do I find the prime factors of 48? How do I just magically know that? Well, you don't just magically know that. You actually go through this process of factorization, and a good method is factor trees. And basically how that works is you just keep breaking that number down into factors. And we're trying to find out what the prime factors are of 48. This is how you would break it down. So basically you draw a little tree, and you're like, okay, what two numbers multiply together to give me 48? Any two numbers that multiply together that give me 48. A simple one is 24 and 2, but you also could have chosen 4 and 12. You can choose either. Both will give you the same answer in the end. Let's just go with this one just because. I'm already at 2. I cannot break down 2 any further because 2 is a prime number, meaning like the only other numbers that will give me 2 are 2 and 1. So I stopped there, but 24 can be broken down even further. So let's say I choose 12 and 2, because 12 times 2 is 24. Then again, I'm at 2, which I can't break down any further because it's a prime number. So then for 12, let's say I break that into 6 and 2. Again, with 2, I have to stop there. But I can break 6 down further into 3 and 2. So then I have found all the prime factors of 48. And as we can see, it's 2 times 2 times 2 times 2 because there's 4 2's, and then times 3 because there's only one 3. So then this gives me 2 to the power of 4 times 3, which will ultimately give me 48. And this top form is also acceptable depending on what you're being asked. Those are the prime factors. Okay, so let's try another example using the number 120. So 120, I have to follow the same method. What two numbers when multiplied together will give me 120? So let's just choose 12 and 10 because that's easy, right? Then both of these can be broken down further. So let's say for 12 we choose to break it down using 6 and 2, and for 10 we break it down using 2 and 5. So for both of these subtrees I've reached 2, which can't be broken down any further. Same with 5. But I can break 6 down further with 2 and 3. And just like that, I've reached all my prime numbers. So then at the end we have 3 2's, so 2 cubed times 1 3 times 1 5. And this will ultimately give me 120. So it may seem a little bit complicated right now, but it's really, really simple when you practice it more. Now, a very important concept in grade 10 math is GCF, which stands for greatest common factor. And basically what that is it's in the name. It's the largest factor that is common to the numbers that you are talking about. So for example, so let's say I'm asked to find the greatest common factor of 12, 18, and 24. One way you can do it is to start making factor trees for all of the numbers. So let me just quickly do that for you guys, and then we can continue to the next step. So once you have broken it down to all of the prime factors that can't really be broken down any further, you start by lifting them out just to make it more organized and make sure you don't miss any numbers. So starting with 12, we have 2 times 2 times 3. Then for 18, you have 2 times 3 times 3. And then lastly for 24, you'll have 2 times 2 times 2 times 3. And then you look at the ones that are common to all of them. So all 12, 18, and 24 have at least one 2, and they all also have at least one 3. But that's kind of it, because 12 has another 2, but 18 doesn't. 18 has another 3, but 24 doesn't. So once you've found all the common factors to all of those numbers, you just multiply them. So then you have 2 times 3, because all of them have 2 and all of them have 3, and then that gives you 6. So that is your greatest common factor. This takes a lot more practice, but it is, once again, very simple once you get the hang of it. Now the last major concept we're going to go over in this video is LCM, which stands for your lowest common multiple. You're basically just looking for multiples in all of the numbers in question that are common to each other. So just to make it simple, we can use the same numbers we just used. So if you're asked to find the lowest common multiple of 12, 18, and 24, again, you need to break them down using factor trees. So once you've broken them down, you, again, as we did with the GCF, you list out all the prime numbers or prime factors for each of these numbers. So for 12, we have 2 times 2 times 3. For 18, we have 2 times 3 times 3. And then for 24, we have 2 times 2 times 2 times 3. Now, to find the lowest common multiple, you find the numbers that are common to all three, right? So you know that 2 is common to 12, 18, and 24, and you also know that 3 is common to 12, 18, and 24. And of course, you multiply them just like you did with GCF, but instead of just multiplying it once, you multiply it by the greatest amount of times that it's listed. So, for example, in this case, for 12, 2 is listed twice, but 3 is only listed once. And then for 18, 2 is only listed once, but 3 is listed twice. And then lastly, for 24, we see that 2 is listed 3 times, where 3 is only listed once. Then you have to look to see is where is 2 mentioned the greatest amount of times, and you're like, oh well, 24, because 2 is mentioned 3 times, and then you have to multiply 2 3 times. So then you have 2 times 2 times 2, and then you look at the other common factor and it's 3, and then you're like, okay, where is it listed the greatest amount of times? And you see that it's at 18 because it's listed twice, whereas for the other ones it's only listed once. Since it's listed twice, and that's the greatest amount of times that it's listed, you multiply 3 twice. So then you have 2 times 2 times 2 times 3 times 3. And that gives you 2 times 2 times 2 is 8, times 3 is 24, times 3 is 72. So then your lowest common multiple between 12, 18, and 24 is 72. Okay, so that was the video going over some of the main components of this first video on exponents and radicals. I can definitely go over some more questions if you need more examples or you want a better understanding on these concepts that I went over in this video. But for now, those are just the fundamentals, and I hope you found this video educational, and I will see you guys next time.